Hello and welcome to the first episode of JittaJabber, the AppSec podcast. We're going to try to get this out every 2 weeks is our goal. Maybe we'll even get to every 1 week. We'll see how we do. I'm JittaJabber. I am one of the co-hosts of the JittaJabber podcast. I have with me Aviram. Aviram is going to be our other co-host. We thought we'd just get together and, like we do generally when we're not recording things, talk about what's happening in AppSec. We do this already offline once, twice, 3 times a week, and we thought the conversation was interesting, so we'll share it with everyone. We'll share what we talk about normally. Aviram, anything to add? Anything from your side that you think that our new guests here on our show should know?
I think that I'm very excited, Jacob. This is the first time that we're doing it. And I look forward to many sessions that we will record together.
I think that one of the cool things that I've liked about working with you, Aviram, since we started is we're at the core, we're both nerds more so than people building an AppSec business. And we just get to work together and build an AppSec business, and that's fun.
Right. That's true. This is exactly why I love working with you. Yeah, I think about myself as a nerd, like a security nerd. And it's a great opportunity for 2 nerds to share some thoughts about the AppSec world and any issues that we encounter on a daily basis.
Well, let's jump into it. So for this episode, we're going to start with a recap of this year because it's been a really exciting year. I think most people probably have heard of some of the things that we're going to talk about from a vulnerability perspective. As someone who's worked in incident response and various other parts of security where I'm focused on one very tower of the security functions, it's always been about vulnerabilities that, for me at least, it's a lot of times been about vulnerabilities that aren't related necessarily to AppSec or the code that my developers have been building. It's like operating system vulnerabilities were historically something that we spent a lot of time on in the last 20 years, or things that weren't related to what my developers in the business were doing. If I was just responding to an incident or when I was consulting responding to incidents, the vulnerabilities that were exploited were often not related to the code that business has been producing. I think that's different this year. Like 2025 has felt to me that a lot of the vulnerabilities that security teams have to deal with are now code that's being developed internally. So you might disagree with me, but Microsoft has gotten substantially better in the quality of their operating system code. They still have vulnerabilities like everyone, but we're seeing a lot of incident response engagements too, focused around people getting into systems via code that was written by that business. And to me, that was a major shift this year. Maybe it's just I'm spending more time focused on this space and it's a bias that I have, but do you feel the same way, Aviram, that this year has had a shift towards more vulnerabilities from code that's written in-house than other years?
I tell you, Jacob, I've been in the cybersecurity industry for the last 25 years. I was doing offensive security and defensive security. And I can tell you, Jacob, frankly, we see vulnerabilities, high-profile vulnerabilities every year. Some will be related to AppSec. Some will be related to the packages installed on operating systems. Some will be related to third-party solutions that introduce those vulnerabilities, and by that they can cause the supply chain attack. So, according to what I feel, and this is only my perspective, every year we see high-profile vulnerabilities from different categories.
Let's jump into, I think, the couple that have made the news first this year. And again, this first episode is going to get us a recap to where we are today. And then the future episodes, we're going to try to talk about things that are very topical. So I think maybe I have my order wrong. We saw 3 or 4 vulnerabilities in the AppSec world that were at least viral. They were relatively serious as well, but they really captured, I think, the attention of both security practitioners and developers. So I want to try to spend a few minutes talking about those, if that works for you, Aviram. Those were TJ actions It was the Next.js middleware vulnerability, the Nginx ingress vulnerability, and then something that's not really a code vulnerability, but is related to how people are working these days, which is an ability for attackers to publish rule files that get included in AI coding tools that can then compromise the integrity of the code. And that's a mouthful, and we'll do that one last. But that's what I was thinking. So let's jump into one of those. Let's jump into TJ Actions. I think you spent a little more time on this one than I did. Do you want to give a quick overview of what happened with the TJ Actions vulnerability and why that was interesting to the industry and the consequences?
Yeah. The TJ action was a GitHub action that was available for developers to use. And actions are pieces of code that developers are using for automation purposes. This one was very popular, by the way, and it was discovered there was a malicious commit that actually changed the expected behavior, and it dumped credentials, secrets into the log of the action. Now, when it comes to public repositories, that's going to be a problem, because public repositories are public and people can gain visibility to those secrets. Since then, that malicious commit was reverted, and now the action is safe to use. But I think it brings back the question about using third-party software, which is not validated or signed. And by that, developers, they just pull a piece of software and like installing it on their premise, in that case, not on their machine, but in their environment. This was an issue.
It's the third party software thing, which I think we'll talk about a little later too in another context, is such a challenging thing for me as a security practitioner to rationalize. I'm a big supporter of open source projects. I think it's fantastic. I want our developers and developers at any company I've worked for or will work for to be able to use open source software to build better things, to participate in the community, et cetera. But it does present a high level of risk, really, because we don't have great visibility into it. And I think GitHub Actions are a great example, right, of a GitHub Action as you described it being a CI/CD pipeline config. And with TJ Actions, I think it really brought that to the forefront. I do think there was a little bit of hype, though, around it that wasn't necessarily warranted. Do you think that's true? And I say that because most companies don't have their code in public repos, especially code with real pipelines that have secrets in them.
I agree with you, but I think it highlights the importance of validating the code that you're embedding into your product. I think this was one of the reasons there was so much hype about it, because I think people understand that, when they pull code, new code, external code, and use it in order to run it or to produce their application, then there is risk which is associated with it. And I think this was part of the reasons that created that hype.
And the solution there, I think, is a couple fold, but I'd love your opinion. Obviously, you have to have your security pipelines and you're embedded into the CI/CD process that are going to scan code. But I think really the human side of this is more important maybe than the technology side, as in education for the developers, but peer reviews of code. I think this is a big thing to me on AI, that peer review of code shouldn't go away, that human review of pull requests shouldn't go away. I think the generative tools are fantastic for developers, but I think the human part's still important. So I'd love your take there too.
I completely agree. The fact that we're embedding AI and LLM capabilities doesn't mean that we need to abandon the old practices of doing peer review and making sure that the code is not vulnerable. I think that also in that case, I think it highlights the importance of using scanning tools to make sure, for example, that the action that you're using is not malicious, or for example, using some runtime capabilities for your GitHub actions, and to make sure that the behavior that you see there is the expected behavior.
I think it's a good segue to another topic that we thought about maybe for this session. One of the things that's interesting to me that's changing is how developers are working with AI tools. And I think it was 2 weeks ago, security research is moving very fast right now in the generative AI space. It's hard to keep up with all the news. So I think it was 2 weeks ago, you saw this research piece posted about how public cursor rules are the instructions you can put in Cursor, a LLM-based IDE, the instructions you can give it on what to do and how to develop your code in a certain way. And it turns out that if you include characters that are not renderable in the UI, Unicode characters, the LLMs may still interpret those as instructions. And so if you publish this cursor rules with these essentially hidden characters, you can influence the behavior of generative coding tools. Obviously, peer review isn't going to be a solution to that. I actually don't know exactly what the answer is to this. It's a tough problem to solve, I think. What's your take? Like, how do we address this where you have essentially something invisible to human review, more or less, unless you're digging into the file, you're looking at converting all the Unicode to a certain Unicode type, or what's your? I'm a little stumped on how to deal with this one, besides only telling our developers to use cursor rules that we've written in-house. And that's pretty much what we're doing right now.
Exactly. I think that first developers should have, some kind of a registry of tools that they can use, like organizational database of tools from which they can consume the rule. It's the same thing like using third parties. Yeah, you can use third-party written rules, and if you don't know exactly what they do, then they can compromise something. I would also advocate using scanners to make sure that the rules are legit and that they do not pose any risk. Same goes with MCPs. I know that we will touch it either in this in our meeting today or in the next one, but also with MCP. There could be malicious MCP servers where in the description you may write instructions to the LLM, and the LLM is going to perform different actions than you would expect, because for the user, those instructions will be undetected or invisible, but the LLM will interpret them and it will take actions based on them. So it's very similar to the rules for cursor and also the instructions in the MCP.
I don't think as an industry we've fully figured out the right answer to do this and do it fast. I think we know how to do it slow. Like, we can process the input of data in a manner that's programmatically slow or expensive to do some validation on these things. But it's not like SQL injection in some ways. In other ways, it is, right? SQL injection, it's actually relatively easy to write secure patterns these days. We know how to parameterize things properly. We know the types of patterns that lead to SQL injection, and you can do pattern-based identification when you're doing input. I think when you're talking about non-deterministic input, where it doesn't follow a certain pattern, like obviously SQL follows a certain pattern, it's a predictable pattern. The language can only handle certain inputs in certain ways. That's not the case when it comes to LLM input, and that's the same thing with cursor rules, MCP, anything that's taking a prompt, if you will, or just text from a human. And I don't want to dig into it too much on this episode, because I think we're going to spend one episode actually just on what we're doing on a research side for this in the future.
I know.
But you can respond to that though, and then we'll change topics.
Just with one sentence, I think it's a very exciting domain to talk about, and we see that we are excited to talk about it. This unstructured commands, it's not exactly like SQL injection, but it's called prompt injection, because you're actually injecting instructions into the prompt. But let's let's keep it for our next session.
So I think we probably want to do about 5 more minutes, and we'll see how this length works for our audience and our viewers. One of the things that was really interesting to me was the Next.js vulnerability. And I can describe this one because I spent some time writing some code to test the vulnerability and exploiting it and playing with it. And it was actually a lot of fun. To me, it felt like an early 2000s vulnerability, which was part of the reason it was fun. In the early 2000s, you had all these remote code injection vulnerabilities that just worked every single time. If the box was not patched for it, the exploit almost always executed the shellcode successfully. And pen testing was very easy in those days because you almost always could find an unpatched machine and exploit it.
Right.
And the Next.js vulnerability is, it was fun. Things are more challenging as a pen tester these days in a good way. But I felt like the Next.js vulnerability was a callback to sort of older vulnerabilities that we don't see very often, where very simply you injected a custom header and it bypassed any middleware. Middleware in Next.js could be anything the user defines, or the programmer defines, rather. And so some people use this for authentication. Others might just use it for validation. Some might, I don't know if anyone has done this, but someone might even use it to do prompt injection protection by using middleware as a layer to clean up prompts. And you could bypass any middleware with a simple header and a cookie. And it's the attack simplicity, I think, is what's so interesting. But it's been around. It's just sitting in that code base for a really long time. Were you as interested in that as I was when it came out, and how it felt like sort of the old days of hacking, if you will?
Exactly like the old days. And those 0-day vulnerabilities are so exciting. And once you find one, now it's already published, but imagine how the person who found it, how he felt that there is a 0-day vulnerability that has been there for a long time. It can be exploited very easily, and
Right.
I think it's an exciting domain as well, and it's kind of going back to those old vulnerabilities that we're familiar with, that we saw in the past. But we need to understand there are still vulnerabilities like that. They're still not known, and then they will be found gradually. And more will be added to code bases. This is how it works.
Yeah, I think part of the reason I really enjoyed this one too is that a lot of the security research on vulnerabilities today invents a lot of drama about it. And Next.js was this to a degree, and I'll explain that in a second why I think that. But a lot of the vulnerabilities are like, if you stand on your roof, you put a finger in the air, and it's a warm Saturday, like it is here in Massachusetts today where I am, actually Friday today. It's a warm Saturday, then it's exploitable. But if you don't meet all of these conditions and you don't have all the normal enterprise security controls and you don't do all these things, then it's exploitable. But I don't feel that as much with the Next.js vulnerability. WAFs didn't have a type of rule to prevent against this type of cookie or this type of header in there. Of course, there was a little bit of hype because you did have to actually use middleware in your application for it to be vulnerable to this. So if you never used middleware, you weren't vulnerable. But it didn't feel like that same type of security research where it's like there's a lot of conditions that had to be true for it to be exploitable.
I think that this is the example that you showed is an evidence that we need to keep taking a look at security and investing in security. And there could be vulnerabilities in packages, in libraries which are unknown, and they can be exploited, and organizations need to protect themselves from those risks using the relevant security tools.
Great. So I think we want to wrap it up here in a minute. Let's give it a little bit of a preview to maybe what next episode will be, which is going to be focused on MCP. And you and I were just talking about this as we're doing some testing. Mostly you have been doing this research and this testing here at JIT. But just as a security person, MCP just makes us uncomfortable. I'll stop there, and you can tell me why you think it makes us uncomfortable, because you and I are uncomfortable about it, but we both think it's amazing technology at the same time, like, or cool technology at least.
Yeah. MCP is an amazing technology. It enables LLM to integrate with tools and third parties and APIs and actually to expand the data set. And instead of just, being focused on the training data, it now expand to a complete ecosystem with different kinds of capabilities, and it can also provide with personalized experience because you can connect it, to your WhatsApp, to your Slack, Discord, and Gmail, and so on and so forth. But with any cool technology, also come the risks. And so this is an amazing technology, but of course we need to put some attention at the risk and to understand them and mitigate them. But the technology should, of course, be adapted because it's really mind-blowing. I just share with you a quick story. I'm playing, with MCPs all the time, and yeah, I installed them. I installed them on a separate machine, not on my own machine. But when you think about it, you take a piece of software, right? You don't know what it's going to do. Yeah, it has a description, it advertises the tools that LLM can use, but you don't know. And you install it on your machine. You give it access to your personal information, and you don't know what it's actually going to do with it. You basically also install a binary. And installing a binary on your machine with no validation, no signing, there's not any approval mechanism that exists today. This creates some, feel that there may be risk associated with it. But anyway, I think that we will keep that, for our next episode. MCPs and the MCP, the framework is amazing, and it's really revolutionizing today the tech industry and what we can do with AI today.
I think that's a good cliffhanger that we can leave on. Well, thank you for doing this first episode with me, Aviram. I had a lot of fun.
My pleasure.
And I hope our audience does as well. See you on the next one.
Bye, Jetta. Thank you.